Imagine for a second, you're sitting at your desk, you grab your computer mouse, you click. But the monitor you're looking at is somehow sitting in a building 6 miles down the road.
Yeah, that would be like the absolute extreme definition of remote work.
Right.
And we aren't talking about a delayed or pixelated video feed either. We are talking a perfectly crisp, zero-lag response.
Okay, let's unpack this. We are looking at a highly specialized, somewhat intimidatingly named piece of hardware from the HDTVSupply catalog.
Very intimidating name.
Right. It's the SmartAVI FVX-3000-PRO-RX-S. So our mission for this deep dive today is to decode exactly what this device does and, why ultra-secure environments absolutely depend on it.
Well, to start, we really need to understand the mechanism here. This device is a single-mode fiber extender receiver.
Okay.
It basically takes your standard 1080p VGA video at 60 Hz, stereo audio, basic USB keyboard and mouse signals, and RS-232 data, and transmits all of them up to 10 kilometers away.
Wait, 10 kilometers, so that's like 6.2 miles? And for those not wiring up server rooms every day, RS-232 is that legacy serial connection still used to control heavy industrial and military equipment, right?
Yeah, it's everywhere in those spaces.
And by single-mode fiber, it means the device shoots a single tightly focused laser beam straight down a microscopic glass core to reach those massive distances.
Right.
It's really like having a magical 6-mile-long extension cord for your computer monitor and mouse.
It sounds like magic, but it's just physics, The signal is encoded into light pulses bouncing off the mirrored walls of a glass tube.
Oh, total internal reflection.
Exactly, yeah. And because of that process, it doesn't suffer from the electrical resistance that would completely kill a standard copper cable after just a few hundred feet. What's fascinating here is the sheer technical muscle required to process that light.
I can only imagine.
Yeah. To handle uncompressed 1080p video and instant mouse clicks simultaneously, this device pushes a maximum data rate of 6.75 gigabits per second.
Wow, nearly 7 gigs.
Right. And that massive bandwidth pipe is exactly what guarantees the fidelity of the experience once the laser finally reaches the receiver.
But pushing nearly 7 gigs a second over 6 miles is incredibly expensive overkill for, like, a standard office.
No, absolutely overkill.
I mean, the only reason you'd engineer a pipe that massive is if the data absolutely cannot be exposed to a local wireless network.
Right, which leads us to the primary use cases from our sources.
Right.
We're talking military and government operations, industrial control rooms, hospitals, and major banking facilities.
Okay, so places where security is literally life or death or, billions of dollars.
Yeah. The use of fiber optics here isn't just about raw distance. It's about impenetrable security.
Right.
Because this data travels as light trapped inside a physical glass connection, it is entirely immune to electromagnetic interference.
So no remote interception at all?
None. You can't just, wirelessly hack into a beam of light from a parked car outside the building.
Okay, let me push back on that for a second. You're calling this an impenetrable fortress, but fiber optic cables still have to physically run underground or through walls, right?
Sure, yeah.
So couldn't an attacker just tap the line or sever it entirely? I mean, how is a physical 6-mile glass cord ultimately safer than a highly encrypted, localized wireless network?
Well, think about it like this. Wireless networks constantly broadcast their existence, which just invites continuous digital probing.
True. They're always shouting, hey, I'm here.
Exactly. Tapping a fiber optic cable requires physical access to the line and highly specialized equipment to bend or splice the glass without breaking the light path.
Oh, so it's not like just splicing a copper wire.
Not at all. If someone tries to cut it or tap it clumsily, the signal drops instantly. The system detects the physical breach the literal millisecond it happens.
Wow.
Yeah, so it immediately locks down the data and alerts security. The physical separation essentially creates an air-gapped vault miles away from the actual human operator.
Okay, that makes the physical hardware sitting on the desk even more surprising.
How so?
Well, you'd expect the receiver doing all this heavy lifting to be a massive humming server rack, right? But looking at the specs, the box is remarkably compact. It's only 6.25 inches wide.
Oh, yeah, and it weighs less than a can of soup. It's just 0.725 pounds.
That's crazy.
Plus, the engineering specs note it can operate in temperatures up to 122 degrees Fahrenheit.
Seriously?
Yeah, I mean, you could bolt this unit into a non-air-conditioned utility closet in a desert military base, and it will keep translating that 7 gigabit laser beam without melting down.
That is wild.
If we connect this to the bigger picture, whether you are designing a secure server hub yourself yourself, or you're just someone who geeks out over the extreme limits of technology, this device proves a crucial point.
Which is?
The invisible backbone of our most secure digital infrastructure is still very much hardwired.
So, what does this all mean? Well, for you listening, it leaves us with a fascinating paradox. We live in an era entirely obsessed with wireless, cloud-based convenience, where everything just floats in the ether.
Yeah, completely.
Yet the absolute most secure way to protect your digital assets is to physically tether them to a 6-mile-long strand of glass. Think about that the next time you connect to the Wi-Fi.
Good point.
While we worry about sophisticated hackers cracking our passwords from halfway across the globe, the biggest security threat to these ultra-secure facilities might just be a guy with a backhoe accidentally digging in the wrong spot.